We're going to go ahead and use a double number line to solve this. Again, our problem states that 15% of $50 is equal to our tip. So this is, of course, the percent of is attached to the whole, and the equal sign is attached to the part. So we're going to go ahead and set up that double number line with 0 and with 100%. And our percent goes on top, and our dollars go on the bottom. So in this case, the whole amount is $50, so that's going to go underneath 100%, and we're trying to make 15%. So we can very easily go ahead and go down to 10%, because we can divide 100 divided by 10 is 10, 5, oh, excuse me, that's supposed to be 50. 50 divided by 10 is 5. So a 10% tip would be $5. So we know that our tip is going to be a little bit more than $5. So in this case, since I need 15%, I'm going to go ahead and find 5%. And I'm going to divide by 2. 10 divided by 2 is 5, and I'm going to do $5 divided by 2, which is $2.50. To find 15%, I'm going to go ahead and add 5 plus 10 to get to 15%, and I'm going to add $2.50 to $5, which makes a $7.50 tip. I have to add that on because my question is asking me for the total cost of my bill. So $5 plus $7.50 makes $57.50. I'm going to go ahead and solve this with a tape diagram. We know that 15% of my $50 bill is going to be equivalent to my tip. So I'm going to go ahead and set up my tape diagram, and I'm going to separate into 10 equal parts. Okay, we know that the whole tape diagram is going to be worth $50 because that's 100%. Each one of these is 10%. So if I divide 50 divided by 10, I get $5. So each piece is worth $5. But I need 15%, so I need to make 5%. So I have to take my 10% here, and I have to split it in half. So in order for it to be a total of 10% each, or 5, it has to be 2.5 here and 2.5 here. So again, I have my 10%, which is $5, plus I have to add to it another $2.50, which makes it $7.50 tip. Add it on to my total bill. To make my total bill is $7.50 plus 50 equals $57.50. This problem says that GameStop was running a deal. If you bought 2 games, you got 20% off the original price. Your discount was $20. What was the original price of the game? Right here, this is the key word to tell me that I am missing the whole. I have 20%. I have no idea what the games cost. And I know that my discount was $20 because that's part. Anytime I have a discount, I have the part. So I have my percent, I'm missing the whole piece, and I have the part. So I set up a tape diagram to solve this. I'm missing this whole piece down here. I'm missing what goes under 100%. I know each one of these is 10%. And this one's 100%. So what I do know is that 20% is a $20 discount. So if I see 20%, which comes up to here, I know this is $20. Well, I have 2 of them. So each one is worth $10. 10 plus 10 makes the $20. So the whole, each individual piece here is worth 10. So when I'm missing the whole amount, I have to add this all up. Well, 10 over 10 times makes $100. So I spent $100 on 2 games. The questions ask me what was the original price of each game. So I would take 100 and divide by 2 to get $50 per game. In this problem, if I wanted to solve it using a ratio table, again, I would have to know that 20% of the whole amount is equal to $20. Okay, so we talk about the fact that 20% is $20, so those two can go together. So I'm going to go ahead and do 20 is 20. So when I go ahead and solve it, I know that I need to get to 100%, so 100 needs to be on top. So in this case, I can immediately go 20 times 5 to get to 100. 20 times 5 makes 100, because this is comparing my percent to my dollars. But I'm going to go ahead and double it and get 40 and 40. I'm going to go ahead and double again and get 80 and 80. And then I would add together 80 plus 20 to get to 100. 80 plus 20 makes 100. So it was $100 total bill, which means that the question is asking me for each game. So I would divide by 2 to get to $50 a game. And if I wanted to use a ratio table to, a double number line to solve, again, we'd see 20% of the original price equals $20 for my discount. So I'm going to go ahead and set this up. And we have 0 on the top, 0 on the bottom, and the 100% is over here. So this is my percents, and these are my dollars. I don't have what's underneath the 100%. That's what I'm working at. But we do know that 20% is $20. So I come over here, I do 20% is $20. So again, I can double it to get 40% is $40. I could double again and get 80% is $80. And I could add together 80 plus 20 to get to 100. So again, I do the bottom, same thing to make 100. Since I'm asking for each game, I take 100 and I divide it by 2 to get to $50 per game. In this problem, it says if there are 4 quarts in 1 gallon, how many gallons do you have if you have 12 quarts? So I'm going to go ahead and set up with a ratio table. I know this is not a percent problem because it's not asking me for a percent or there's no percents in there. I'm comparing quarts to gallons, so I'll put Q on top, G on the bottom for gallons, and it's 4 quarts to 1 gallon. My target number is 12 quarts. Since quarts is on top, I'm going to put 12 on top. I can see that I can immediately multiply by 3. But if I don't see that, I can go ahead and double it to get to 8 quarts makes 2 gallons. And then in this case, I could add together 8 plus 4 to get to 12. And then I would add together 2 plus 1 to get to 3. So there are 3 gallons in 12 quarts. I'm going to go ahead and use another ratio table to solve this problem. This says Olivia paid $25 for 4 shirts. If you purchase 11 shirts, how much will you pay? This is not a percent problem because it's not asking me for a percent or looking or giving me a percent. So in my ratio table, I'm going to go ahead and set that up. I'm comparing dollars to shirts, and it's $25 for 4 shirts. My question's asking me for 11 shirts, so 11 has to go on the bottom. And as you can see, 4 does not go into 11 very easily, so I'm going to have to go ahead and work my ratio table. I'm going to double it. So for 8 shirts, I'm going to go ahead, it's going to cost me $50. And I'm going to go ahead and double it again and get 16 is going to cost me $100. So at this point, I see that I'm past it by 5. Well, I don't have 5, but what I can do is I can divide by 4 to get down to what it would cost me for 1 shirt. So I'm going to go divide by 4 to get to 1, and I'm going to do 25 divided by 4. So in case I didn't know what 25 divided by 4 is, I can come off to the side and I can do this. 4 goes into 25 6 times. That's 24. And I have a remainder of 1. And we talked about the fact that after 25 comes a decimal and I can put a 0. So I can drop the 0 down. And then it becomes 4 goes into 10 2 times. That's 8. I subtract, I get 2. I can add another 0 because I can put as many zeros as I want in the end. 4 goes into 25 times. We've also talked about the fact that it does not make sense that it would cost $625 for 1 shirt. So we have to make sense of our answer, and we can see that the decimal will go right here. So it'll be $6.25 for 1 shirt. So from here, if I wanted to, I could multiply by 11, but that might be hard for me to multiply 6.25 times 11. I could multiply by 10 and we could make this 10. Let's do that. We'll make that a 10. 1 times 10 is 10. 625 times 10, and we know our strategy here. We're multiplying. We move the decimal one place back, so it becomes $62.50. Remember to put the 0 on the end. And now I can add these two together to get to 11. So if I add $62.50 to $6.25, we have $62.50 to $6.25. That makes 75 cents. And that makes 68. So when I want to buy 11 shirts, it would cost me $68.75. That's my final answer. In this problem, Elizabeth ran 20 miles in 150 minutes, and we want to know her average speed. So typically when we talk about running, we're talking about how many minutes it takes us to run a mile. Or we can look at this and say, well, how many miles can she run in an hour? So we're going to find two rates here to describe this situation. I'm going to go ahead and set up a ratio table. And I'm comparing miles and I'm comparing minutes. And it says she runs 20 miles in 150 minutes. Immediately I see they end in 0, so I'm going to go ahead and divide by 10. So she runs 2 miles in 15 minutes. If I divide by 2 now at this point in time, which she would run 1 mile, and if I divide 15 by 2, half of 15 becomes 7.5. So she runs 1 mile in 7.5 minutes, which means 1 mile in 7 minutes and 30 seconds. Now, in the same respect, what we can do is if we wanted to, we could calculate how many miles she runs in an hour, which would also be her average speed. And so what would have to happen is, since we have minutes, we know that 60 minutes is equal to 1 hour. So we need to get 60 on the bottom. So I can see that I can do 15 times 4 to get to 60. Or what I'll do is I'll go ahead and I'm going to double this column. So double 2 makes 4. Double 15 makes 30. And if I double 30 again, I get 60. If I double 4, I get 8. So she runs 8 miles per hour. Either one would be an acceptable average speed.